Doug,
Sean,
how you been?
good to see you, man.
You looking good for, what are you, 79 now?
I'm getting up there, yeah. I don't look as good as your AI photo, though.
I don't even look.
That came
I
out
was
really
trying to
good.
figure out, it's the tan. I don't, gingers don't tan, right? Where are my ginger brothers and sisters at? I can't see you.
Sean and I built this deck together, and we kept going back and forth, and I kept noticing every time he sent me a revision of the deck, his picture got bigger and better looking every time. Well, real quick, we'll introduce ourselves, we'll talk about the format, and we'll get right after. We got a lot to cover, and we got only 45 minutes. So, Sean, why don't you start off, introduce yourself, and I'll pick up from there.
It's good to be here in Washington, D.C. I came from the other Washington, where I work at NVIDIA. Although I'm still kind of new at NVIDIA. I was at Microsoft for 25 years, designing and building data centers. Part of that was with this guy. And one of the things that I'm hoping to do today is bring a little like realness to all this data center hype that we're seeing to some of these white papers.
Absolutely. So yeah, that's Sean and I go back to Microsoft. I led Microsoft's design, build, and construct for many years. Many of you know me in that space. Then I went to Meta on the R&D side and worked on helping rationalize what AI workloads do to the design of a data center. And then now I'm out there advising private equity, sitting on boards, and just trying to make an impact with you guys as we face these big challenges. So what we thought we'd do today.
In the Army too.
Oh, I did a little time in the Army, yeah.
Thanks for your service.
Yeah, thank you, yeah, 33. Well, you, submariner, you know, they are the popular ones with the data center crew.
That's right, that's right. Hey, can we do a quick poll? All right, raise your hand if you were in the Navy.
Yeah.
I see hands.
Yep. Okay, watch this. Raise your hand if you were in the Army. I don't see any hands.
I saw one right over here.
One over there? Okay, sorry, I didn't see it.
Yeah.
Okay.
Yep.
You see?
Marine Corps, Marine. Does everybody know what Marine stands for? My ass rides in Navy equipment.
All right, so we thought it'd be fun just to talk about this industry scaling and what are some of the things that there's so many things happening so quickly. We just picked a few out that maybe are thematic, and we won't have a lot of time to go into each one of them, but we've created a QR code and each slide with the actual white paper and some resources you can go back and learn more about. But we've taken this format of making silly movie posters, and we're gonna kind of take turns presenting the ideas and then giving it a thumbs up, thumbs down, and talk about the critiques for it.
Do you think anybody even remembers Siskel?
Who even knows Siskel? Okay, okay. Yeah, of course, Rich. We're the same. Let me grab the clicker here. All right, what do you think, Sean? Get ready?
Yeah, Siskel and Ebert, they used to critique movies, and they would argue a lot. They would get into it, but it was real, right? It wasn't like, oh, I love the movie, I love the movie. It was a great way to get to know the movie in a deep level, hearing the banter back and forth.
Yep. And the beauty is you don't have to watch the whole movie. You just get to hear us talk about these ideas.
That's right. That's right.
Okay, I think it's
what are we doing first?
I think we're going to do data centers in space.
So this paper was written by one of these data center startups that has designs to put data centers in space. And Doug, what I really liked about it was, first of all, of course, the disruptive innovation. I really liked that they were thinking, you know, hey, listen, you know, there's no reason why we should be stuck to these concrete warehouse type buildings, that there's actually a lot of opportunity, you know, beyond our atmosphere. And what I also really liked about it was just some of the engineering thinking. They went through and they were looking at some of the problems that they would have to, you know, come up against and how they would solve those. Yeah. What did you think?
Well, you know, we did some space stuff when we were at Microsoft, the orbital program, and
right, yeah.
we put these big satellites to connect, and we'd ask, what's the next step? Oh, we need this many rocket missions to get, you know, a few servers up into space and make it work. So I think it's a crazy idea. I have mixed feelings about it. If we look at,
You're not in love with it.
I'm not in love, but I think I'll come back to maybe I am in love with it. 33 gigawatts installed base we have in North America right now. By 2030, the low side is going to be 60 gigawatts, doubling. The high side is 90, you know, tripling. How much data center in that and that nut that we got to crack, can we get up in space in that much time? I don't think a whole lot. So that's why I kind of pause at the practicality of it to scale. At the same time, who used Wi-Fi on their plane to get over here for this trip? Yeah. Yeah, it's a variable experience, but that's us using space for our data, right? I was using AI through a satellite back home, and I think if you got maybe a Blackwell up there, something up that could cache a little bit like an edge site, yeah, that could be pretty cool. So that's my mixed feelings.
I think you're gonna have to get over it. I think it's the future. Yeah.
Well, I am old. Change.
You're gonna have to get over it. I think we will. It's inevitable. We will see accelerated compute in space, and part of the reason is because of how slow it was. It's a bandwidth issue. So what we see going on right now is the cost of launch is getting extremely cheap. So that's allowing governments and companies and even universities and private citizens to put more and more stuff into orbit, peering down on Earth and peering out into the cosmos as well. But it's all very heavy, high file size, very, very raw information that needs to be processed first. And if it can be processed down to the essentials, down to just the information that you need, the packets that are sent down to Earth are going to be much, much smaller. So you're going to be able to have this pre-processed information that you're going to get at much real time, and that is what's going to drive computing at pace. Now, are we going to see these giant like concrete buildings floating around there? No, of course not. I think people that try to say we're going to have many, many gigawatts in space, I think they're missing the point. The opportunity is this new economy that's forming out there.
I think you're making a good point. It makes me think about like developing countries like Africa. They just skipped telephone lines and went straight to cellular, right? So maybe this is a way to get developing countries, compute capacity faster, because we all know the AI movements are train, infer, and get out to the edge. So maybe this is a way to reach more people too.
Absolutely, yep. And if you think about it, there's already computers floating around in space already. So at what point does the compute become a data center, right?
Yeah, fair point.
So what do you think? Thumbs up? I'm thumbs up.
I'm right in the middle.
In the middle.
The practicality, but also just the acceptance that we're doing it already, and it could help us a lot. Yeah. All right, next one. I'll take this one. So this is this is crazy. So Sean, what this is an idea to create a gigawatt-hour water tower, and it's going to be 620 meters tall. Ask me why it should be 620 meters tall.
Why does it need to be 620 meters tall?
Funny you should ask.
Wait, meters or freedom units?
Meters.
Okay, meters.
It's because that's the highest tower height the FAA will license so you don't impede air traffic.
Oh, so people aren't crashing into it?
Right. So this is from the folks from Skidmore, Owens & Merrill, one of the biggest architectural firms in the world, combined with a firm that we may know in our space, Energy Vault, which is a company that was making these systems of taking these concrete blocks and bringing them up, creating potential energy, gravity potential energy when the power was low and available, and then dropping it when it was at peak to create some peak shaving with gravity. This is the same thing. It's just pumped storage is all it is. It just happens to be so massive, 3 times the height of a windmill. Why does it matter? Why are we bringing this to you? I'm bringing it because I think it's important to recognize that in the last, decade plus, every time a data center was built by the hyperscalers, they do a complementary investment in renewables to offset their scope 2 emissions. And we have now a pipeline of wind and solar. No matter how we feel about it politically, it is out there capitalized, but less than half of it, billions of dollars of renewables, less than half of it is actually hitting the grid. Why? Because it's an intermittent load, and our grid does not like intermittent loads. It's trying to rationalize it through the interconnect process, and it's kind of freezing their brains a little bit. So we have a lot of capacity we've already paid for that's stuck. Something like this, it's essentially a big old gravity battery, can help unlock some of that solar, some of that wind, and help the utilities rationalize how to connect to this investment that's already there. Now.
Yeah, I mean, your point about the energy storage is unimpeachable, rock solid. We need more energy storage. We need better batteries. We need long duration energy storage. Lithium ion is great up until about 4 to 6 hours, maybe 8. But then you need something different, right? Pumped hydro, I mean, it's the cheapest form of energy storage. People are hollowing out the tops of mountains, and they're making this work. This is a target-rich environment for critique on this particular paper. But the thing that I had the hardest time about, Doug, was doing it behind the meter. Behind the meter. So, I mean, if there's anything I need to set the record straight is data centers, we don't want a lot of stuff behind the meter.
Yes.
We're putting power plants behind the meter because we have to, not because we want to. Here's a dirty secret. A lot of us who have online services, we don't even want data centers in the first place. It's just a necessary evil. In 2005, when Microsoft decided to start building its own data centers, it wasn't because we had this ambition to be a construction company. It was because we couldn't get enough capacity. And so the proof of that, by the way, is if you go and you look at the last earnings report, about half of Microsoft's capacity is leased. Like we're perfectly fine with doing stuff in other people's fences, right. Just like energy storage, and on site. So that was the hardest part. Is when I think about how hard it is to build a data center today.
Yeah.
And now we're trying to
skyscraper right next to it.
Oh my gosh, yeah. I mean, to think about the logistics with that, how much stuff are we going to try to pack behind?
I think
the
you have to build a railroad first.
Yeah.
To get everything there. I agree with you on behind the meter. This is a behemoth right here. I think where this belongs is close to those wind fields and solar fields, where it can become something that modulates, the power. That's not a good word, but smooths it out a little bit. I do agree with that, and I don't think we quite understand what it takes to build a 620 meter, silo, if you will, out of concrete. That's going to be a lot of scope 3 emissions for sure.
That's right. Yep. Yeah.
But nonetheless, it's a hard problem we need to be thinking about. How can we unlock investments we've already made? How can we help the grid rationalize more load so we can not have to do all this behind the meter power? That is a tactic, not a strategy for our hyperscalers. Trust me, you don't want to be building a power plant while you're building a data center competing for the same labor and materials. It's not best practice.
But we will if we have to. And I suppose we'll build 620 meter water towers if we have to. But there's so many other energy storage technologies out there that I didn't see a lot of quantum. I didn't see a lot of comparison on cost per kilowatt hour.
That's, I think, the next step for these guys. The QR code here is a website, folks, and it's password protected. The password is on the slide. It's called, just put guest in there and you can see it. I think they're still trying to sort out the use case. I think they thought, hey, who has the most money? The hyperscalers, of course they want a 620 meter tower by their data centers. I don't think that's the application yet. They need to find the right use case.
What they ought to do is put that in space.
Now we're talking. Just put a rocket engine on the bottom of it. So, Sean, thumbs up, thumbs
Sorry.
Oh,
sorry, I need more. I need more before I'm building those towers.
Thumbs up because it's good thinking. Maybe not.
Energy storage, yes. 620.
Concrete.
I'm not there yet.
Okay.
I'm not there yet.
All right, fair enough, fair enough. Okay, next one. Why don't you take this one on?
Yeah, rethinking load growth. I'm going to say something controversial to a lot of people. We're not running out of energy. We're not running out of power. There is an enormous amount of power in the world, in the US. Our grid is built so that there is enough capacity, enough infrastructure to power all of our needs in the most extreme scenario, like the middle of an unusually hot summer, middle of the day, everyone's got their air conditioner, and 4 or 5 power plants have gone down for maintenance, and 3 or 4 have failed because something broke. So it's designed for the worst case, plus some, plenty of energy. What this paper is talking about is, why don't we take advantage of all of that margin for powering data centers? And the thesis here is, data centers would be willing to take on more risk. We'd be willing to purchase non-firm power. We'd be willing to say, you know what, give us 100, 1,000 megawatts, and if you need it back, we're willing to give you back for those very rare instances where what that margin was built for, these emergencies. And I think it's a really good idea for a couple of reasons. Number one is the speed. I mean, right, in our industry right now, our currency is speed. It's not finding necessarily the cheapest form of capacity, it's finding the fastest. And so this is infrastructure that's already built. The second thing is it's monetizing infrastructure that's already been invested in. I mean, these utilities have already paid for the power plants, the transformers, all that kind of stuff, but it's sort of locked up sitting there idle. Well, they can now sell that capacity to data centers, right? So I think that's good for everybody. What did you think?
Well, I think what I also picked up, this theme of batteries, I think what they need is a 620 meter silo to help smooth out their loads. No, but what hit me about the paper was like, hey, we don't have this massive grid has to double kind of problem, exponential growth. No, it's like single digit growth. And how do we help the utilities get to a place, or how do we understand what they need and figure out how to partner with them to do exactly what you're saying, put that energy to work. And it may be some sort of a battery or capacitor that helps us do that. I don't know. Did the paper go into like the solutions that would be needed to make it happen?
It was light on the solutions, fair enough, but it did point out the opportunity.
Yeah.
That there's between 100 and 200 gigawatts available right now. April 22nd, right now, there's capacity to be had. But fair point with that. I think the other thing that it was a little light on is technically, how do you get that capacity to your site? You're gonna have to build more transmission lines and things of that nature. So that's the hard part. And that actually trips up a lot of projects, is getting, if you're building a large, wind or so, you've got some experience with some of these projects where it gets built, but you can't get the capacity out.
Yep.
Right? It always comes down to these transmission lines.
And linear infrastructure is a tough time because you're having to, negotiate with mom and pop landowners all the way along the line to get it going. I think there's another thing, I just hit it briefly. We're seeing a lot of behind the meter power. I'm curious, if we are right in the U.S. for another act like the PURPA Act, the Power Utility Regulation Act of 1976, brought about by the oil embargo, where essentially promoting alternative fuels like cogeneration, and anyone could build up to 80 megawatts to support their own facility, and then the utilities had to buy the excess power. I'm curious if there's like a turn that idea on its head, and after all this island power is out there producing and the private developers have made their money, how do we repatriate all of that power back to the grid so it's paid for by commercial industry, but it benefits ultimately the people and the utility at the same time and has a second life? So I think that could be one of the solutions that could help us unlock the grid a little more and take advantage of the investments already made.
So while you're in town, maybe go knock on Chris Wright's door at the DOE and pitch that. Yeah, absolutely.
It starts with a love letter from the Secretary of Energy, for sure, to the FERC, and then we see where it goes from there. Yeah,
see where it goes. Yeah.
So,
yeah, 2 thumbs up for me on flexible data centers utilizing infrastructure capacity that's already there.
Yep. I give a thumbs up also. I think it's the right idea, the short on solutions.
Short on solutions.
Yeah. All right, shall we keep going? All right, here's one I want to share with you guys. And Christian Bellotti was here, he would, maybe shudder or be happy. He's a growth mindset guy. But is PUE the thing we're really worried about in this day and age? Or is it really the dirty secret of our industry, and that is basic utilization of the IT stack, right? If we look at the hyperscalers that don't consume their own load, so that takes search out of it, take Meta out of it, because they're consuming their own load, their utilization is a little higher, not 100%. It's about like maybe high 70s, 80s. But if you look at the cloud providers that are putting tenants in there, they're all different maturity levels, we see an aggregate utilization of like 60%, and I'm being generous. So that means if we buy a 100 megawatt data center, we design it to the nameplate of the servers, but our consumption is rarely and never 100%. So what can we do to help drive up utilization without breaking the business model is kind of what what this idea is about. And there's a white paper out there by this company, Veris, who's got a few data centers in development, and the white paper is titled Beyond PUE, What's Next? And they're talking about how do we take aggregate utilization and drive it up. Conceptually, what they're talking about is they would create an MV, a medium voltage plane along the back side of the data center that could dispatch power to different pods based upon their consumption. And at the heart of it is an industrial battery that can be the draw and the recharge. If it's running low, it can be recharging the battery, so that we can actually drive higher utilization behind the meter while just using batteries and more innovative lineups. I think this is not a new concept. Look at the hyperscalers. Remember we had Flex at Microsoft that was attempting to solve the same problem. I think Google is doing some things to also try to solve this problem. So I would say these guys are not like doing something no one else is doing. They're probably a first mover out there getting some traction in the market. But I think conceptually, it's really about efficiency and making the most of the power that we're buying. So we're not buying and provisioning all of this kit, all of that scope 3 emissions, all of that cost, all of that time, when it may not be necessary, if we could find the right solution that gets it right.
Yeah, I think this is. I think you're acting like you're still in the Army, Doug.
Not again.
You can't just go and tell the engineers that are in charge of these services, we're going to oversubscribe the data center, and there's a risk that your stuff is going to go down. Matter of fact, I think that there's another industry that tries to do this, the airline industry.
Right.
And every once in a while, we see a YouTube of somebody getting their ass kicked by police as they're getting yanked off the plane, right? Yeah. It's a very nasty.
Just take the $1,000.
Yeah, exactly. There's no upside to fighting with the police. Everyone's got their phones out. You're going to look like a clown. But when it comes to oversubscribing data centers, I totally agree with you. Like the underutilization. I mean, go ahead and just yell it out. Who knows what the average utilization of a data center, what data centers are across the U.S.?
60, 70, we're in 60.
Yeah, right in there. It's about 66%. It's about 2/3. And I mean, especially when you're looking at like
gigawatt campus, that's 400 megawatts just not being used.
Right?
Yeah.
And we're over here by Data Center Alley. I mean, all of that capacity, it's only about 2/3 being utilized. So that's painful for, I think, a utility to then have to build all that infrastructure that they can't monetize.
Right.
Although I think they're starting to figure out that game, especially in Dublin, Ireland. They've sort of figured out that game. It's painful for people, that have to build a data center and pay for it.
Right.
Their 100 megawatt data center, they're only getting 2/3 of that investment. And it's also painful for the servers. I mean, the servers are expensive, and they're not getting full utilization out of those also. I just don't know what the right solution is. I think everyone assumes it's oversubscription, but I haven't seen it work successfully yet.
I agree with you. We struggled at Microsoft to actually make these concepts work. I think it's going to take people making a first move and learning. I'm sure, success is not the teacher. What does Mike Tyson say? No plan survives the first punch in the face.
Yeah.
These guys are probably going to get a few punches in the face as they go through this, but I applaud them for making a position. We're going to try to solve this problem.
Yeah, I remember that. I mean, when Doug was at Microsoft building the data centers, you were shaming these people on the utilization.
Yeah.
Like, okay, I'll build another data center, but you've got 3 or 4 sitting here already built in underutilization that you could go after.
Yeah. So what do you think, Sean?
Well, I think I'm right in the middle. First of all, I've seen Veris's solution. I think it's going to work. I'm a big fan of Veris, and I know they are also, speaking of PUE and Christian Bellotti, I know we all get together and talk. I haven't seen it work yet. And in almost 3 decades of dealing with underutilization, we've always complained about it. We've never been able to fix it. So that's the only reservation that I have. So yeah, I think I'm right in the middle.
All right. So I am optimistic that this is the solution we need to be. This is the problem we need to be solving. Is this the right solution? We'll find out. But super thumbs up to encourage this kind of innovation and get out there making it real and taking the first hits on that. Yeah, for sure.
So that's your standing order as the CO.
Yeah.
You will oversubscribe.
Yeah. And then you just like do a reverse auction or something. I'm sure there's some ways, you know what I mean? I got a trip to Hawaii one time. I just got off the plane, you know? Can we do that with a workload? You get
off
you
the
get a
plane.
car.
Just get off the
Get
plane.
off the plane, yeah. Okay, so, all right, we're moving along pretty well. This is pretty good. So shall we do the next one?
Yeah, let's move on.
So
Principal scale, this was your paper.
well, yeah.
So Doug, everything you said is right, but I thought there was some naivety. So why don't you just give us a quick overview and then I'll
Okay.
let you have it.
All right. So as opposed to solving discrete problems, I thought, what is a principled approach we could take to solve this exponential growth problem ahead of us? And I put forward that there's three basic ideas that we should all be thinking about. Number one, efficiency. You know, let's make simple the design so that it takes less time, less money, and carbon. So that's just a efficiency. Number two, democratization of data. If somebody is getting something right, let's share that. Look at the utilities from 1920 to 1960, grew 2,500%. And it started with AC grids, DC grids, completely different solutions, kind of like our data center world right now. But it ended up being standardized, modularized with how we're going to handle voltage, how we're going to handle current. So I think we're on that same journey. I'm not saying we're going to become a utility, but I'm saying our data centers are a necessary evil. They're not that special. Something that we should all collectively learn and get better together. Another example of data democratization I'm very proud of in our industry is safety. If you look at how many hours are put by construction workers on site, and you measure the OSHA standard of total recordable incident rate, that's how many people you hurt in a 100-person census in a year, those rates have gone really well down. Millions of hours being worked by your teams out there, and I'm very proud of you for that. Making these sites more disciplined, more safe, and everyone sharing what works. That's a good example. Now, the backside, the ugly side of that story is, in the last 10 years, the fatality rate, is how many people die on a construction site per a census of 100,000 in a year, has not changed in the last 10 years. So we see on LinkedIn, hey, 8 million hours, look at us. But we don't say, hey, we killed someone. And here's what we learned. Please don't make the mistakes we made. Let's
So what you're
share
saying
this.
is the recordable incident rate, that people getting hurt have gone down.
Yes.
The fatality rate.
The rate of fatalities has been flat for the last 10 years.
Why is that?
Well, that's my next white paper, is try to bring a call to action to understand that. Yeah, I'm collecting data from Europe, collecting data from North America.
Wow.
And not only that, for every one person that dies on a construction site, 4 people take their own lives. Yeah. And we apply these rates of incidents to the volume ahead. There's going to be a body count, folks. So more to follow on that. I think it's a whole subject worth really evangelizing. So that's democratization of data. Then the third one is disruption. We have to be open to systematic disruption. Someone is going to have to do something different. You know, in the data center industry, we're like, yeah, we love innovation as long as it's been around for 10 years, right? So we're going to have to break that mold and start to like, okay, who's going to be the first mover? Who's going to take the hit and figure how to do something? That is so important. So I think those are the 3 principles I try to talk about, not auguring on a solution per se, but how would you organize your thinking and strategy on principles?
On principles.
Yeah.
I mean, I think they're all solid. One of the things that I really had a hard time picturing was the democratization, you know, the sharing of the lessons learned, the sharing, you know, inside of a company when you've made a mistake, when a team has made a mistake inside of that company, and then being able to publish it and tell everybody, hey, our thesis was this, we tried it, and it didn't work. We don't see those types of stories very often.
I think that's a maturity thing. You know, look at the medical profession. You know, they have postmortems. When they have a bad outcome, they gather everyone and the people just own it and they talk about it and they make sure people aren't making that same thing. In fact, the checklist manifesto came from a surgeon that left a tool inside somebody's body and said, "Oh, we got to figure this out." Yeah.
Okay, that's a good point. Yeah, the lessons learned.
But you got to get open with being vulnerable.
Yeah,
And
exactly.
I don't have all the answers. I made a mistake, and let's solve it together.
I mean, my experience at Microsoft, and I know this is the case with the other hyperscalers and a lot of companies, is they're selling a brand. And this brand needs to also sort of show excellence. And that's why I think it's hard for a lot of companies to say, hey, listen, I tried this and it didn't work. You have to sort of like dig and discover.
Yep.
You know, hey, you guys said you were going to do this, and then you stopped publicizing about it. Like, what happened? You know, let the rest of us learn from that.
Right. I think we suffer from this zero defect environment, right? You can't show any vulnerability, any weakness, so therefore you cover those up. And that's human nature, I'm sure, but it's something that we'll have to mature through. Yeah.
What you're saying is if this industry can get over that, it'll help accelerate the innovation.
I mean, look at the electrical case study, you know, Edison and Tesla, they were completely, you know, going at it, you know, and no, you're wrong, no, you're right. And then ultimately it all landed on whether it's right or wrong, I think people could argue. It landed on a solution and a way to standardize. And with that, scaling through World War II, scaling through the baby boomer expansion. So that's what we need. We need to be able to scale.
You'd be able to scale. You touched on another thing too that is personally extremely important to me, and that's the human factor. Obviously, when I would go visit a site, you know, I would see all of the craft labor, right, and get to know them. And the last thing in the world you would want to see any of them get hurt or, God forbid, you know, killed on a site. But it happens. Well, here recently, you know, my son's made the career decision to become an electrician, and I know yours has as well.
Yeah.
And these are, and so like my baby is showing up at these job sites.
Scary as hell, isn't it? Yeah. Yeah. Everyone is somebody's child. Yeah.
Absolutely. I mean, I'm very happy for him. It's an extremely honorable job. I did it for a while. It's a very honorable job, and we need more of those to help build our data centers and our 620-meter skyscraper pump storage system.
Yes.
I'm very happy, and yeah, I just, you know, I know he's going to be coming home with Band-Aids on his hands, and he's going to be coming home with maybe a sore back and stuff like that. But I hope that the contractors and the companies that are working for take safety as seriously as you did when you ran construction at Microsoft.
Yeah, I think that's the obligation we have, our covenant. Good. So, thumbs up, thumbs down, I'm dying to know.
I want to give it a thumbs down just to give you a hard time, but I liked it. I'm going to give it a thumbs up, yeah.
I give myself a little sideways, Pollyannish. It's a little Pollyannish. I avoided the hard conversations. I just kept it too lofty. So, yeah, stuff to dig into for sure. Now, this next paper is really interesting. This is your white paper. What data centers?
Did you even read it?
I did. I got AI to help me understand it because there's big words I didn't know and concepts I couldn't get my brain around. But so I don't butcher it too badly. Why don't you give the premise like I did, and then I can tell you why it's a bad idea.
So 6 months ago, I kind of took an inventory of sort of all of the barriers that we were facing with, you know, building out data centers, from energy to network to people and all that kind of stuff. And I just took a bold step of saying, this is what we need next. And, you know, a lot of it has to do with energy. You know, we talk about, you know, flexibility. So I think a lot of things have worked out. But you know what I'm thinking I'm going to do is in about 6 months, I'm going to write another one, and it's going to be what data centers needed next, but they didn't get. Yeah. And hopefully I can sort of explain some of those.
I thought you brought some great concepts forward, like an integrated solution from the chip to the grid. I mean, we had to think about it holistically. I thought that was a powerful concept. I thought your ideas about, you know, we need to find better ways to manage power within the data center to deal with these you know, big pernicious AI work profiles that happen when they're working. That's a powerful concept. you talked about the need for our fiber optics, and we don't even talk about that, but our fiber optics have to grow at a same rate as the technology that we're serving. And then I don't think we're all getting our brain around exactly how many fibers that really means as we get to these really high densities, high performance compute systems.
That's right.
So you brought that up really well. I think you really missed the mark on cooling. I'm just got to say, you kind of augured in on immersion cooling. I think you're a little wet on that one. I think the industry has not gone that way at all yet. So maybe
On the immersion cooling?
immersion cooling.
Yeah, I agree.
Now there's some Bitcoin miners
It's
out there
cool.
doing it.
I mean, you put this thing underwater
Yeah.
and it boils, but we're getting it done with cold plates. We are getting it done. And I'm seeing a lot of partners in the room here that have helped us get it done.
Absolutely.
Because it's from an operational perspective, it is much simpler to work with a conventional server case than these giant baths.
Yes, a lot of logistics around the water. And then you talked a lot about power behind the meter as a necessary, function. And you did a great job talking about the renewables, but the place we're now is we're just seeing combined cycle gas, coming hard at us. And I think that's something that we'll have to be reckoning. So maybe in the update of the white paper, talking about the second and third order effects of what has happened, to meet our scaling. But I thought you did a great job of committing to some ideas, whether they're right or wrong, because they're, perishable.
Is there perishable? I mean, the fact is, our industry is evolving at the fastest rate that any other industry has, right? So whatever you're learning today, it could be proven wrong, very, very, very soon. I think a lot of people are looking at NVIDIA to tell the world what's next. And, when it comes to density, you get these giant supercomputers that we're scaling up, to your point about scaling. At one point, supercomputers, there's like maybe one or two in a university or somewhere. Now we're building giant warehouses chock full of supercomputers. So what's next? And I think we're dealing with problems we never thought we were going to deal with. For example, these fluctuating training workloads. You've got thousands of servers in a data center, and they're all running this same workload. And that data center load is going up and down. And it's fascinating because when I say chip to grid, that is the new compute system. As a matter of fact, if servers in a data center are going up and down, you can be standing next to that turbine many miles away, and you can hear the turbine going up and down to follow that load. It's fascinating. That is the new compute system.
Yeah, that was a big awakening for me, realizing our grid's basically designed to turn motors, not to run electronics. And we're driving electronics at such a scale and doing things we never expected. It's creating more need for that capacitor. The big theme I've seen in these 6 technologies is the need for batteries or some sort of buffering to help, kind of smooth things out for sure. So I think I'm going to give you a middle.
A middle?
I'm going to give you an up for making a bold statement and committing. You couldn't predict the future, so I'll give you a thumbs up on that.
Okay.
What do you give yourself on this white paper?
Doug, if I could go back and rewrite it, I missed an extremely major point about low voltage ride through. This isn't some nerdy thing. This is like
It's a nerdy thing.
front and center. Okay,
It's very nerdy.
This is front and center to a lot of us that are designing data centers right now. How are you going to deal with low voltage ride through when you're working with the grid and stuff like that? So I wish I would have, I think it's maybe a C+.
I wouldn't say that.
And that's one of the major issues. I think the other thing is I didn't really hit the behind the meter issue front and center.
Yeah.
And the fact is we have to build power plants sometimes, not all the time, but it shouldn't be like the first thing. And what we've done is, accidentally, what we've done as an industry is I think we've misinformed the world that that's our top choice. Given the two, a grid connection or a behind the meter connection, we'd rather go with a behind the meter connection. It's just not the case. So yeah, I think I missed the mark on those two things. So
Yeah, that's a huge point. Everyone gets frothy about behind the meter power. It's like, man, we don't want to do that, but we have to do it because the grid can't keep up, and that's a really good point you're making.
how are we doing on time?
We're doing really well, actually. We have 5-minute buffers.
Take one question.
Yeah, we'll take one question. We'll put a little thank you slide up there with the QR code.
So we got microphones. AV guys, is it okay? I know we didn't say we were going to do questions, but we wrapped up
okay?
early.
Can
we do that?
Anyone have any darts to throw at us?
Questions or comments or corrections?
Okay, all right, right here. It's not working yet, but I can hear you. I'll repeat the question.
Okay, my question really focuses on a couple of things. One, you mentioned that you want to sell the excess power from a behind-the-meter plant to the grid, but when you do that, you don't have any power for your data center.
Yeah, that's a great question. Yeah.
That's an interesting problem. The other one you mentioned, I'll follow up, I got a couple real quick. And the other one is, you also mentioned that when we pay this thing off, that's gonna be great, because then we can sell it to the grid.
Yeah.
Will you expect the data centers to go away?
Yeah, I think that's a fundamental flaw in my logic. I agree with you on that. But if we're utilizing only like 60%, you know, maybe there is this 40%. So it's I don't have good answers, but I think in that inefficiency of how we provision power to our chips, I think that might be the opportunity there.
Because when you're
Great question.
when you're moving power to the grid, you have to make it the priority, which means you're always subject to dispatch, and that means you go offline.
I think you're exactly right. I think we have to be like growth mindset here to figure out, okay, what's the assets that we've now ended up with after we had to do what we had to do? We haven't solved utilization. How much surplus power do these guys really have? And we'll run them for like a decade or so to get the pro forma runoff. And I think if we stay open, and that's why we might need to have like that national act to like really say, hey guys, these guys have extra power, and utilities, you need to take it. Does it solve their problem completely? I don't know. But I think you're hitting on some really good weaknesses in my arguments.
So in 5 to 10 years, there's going to be thousands of megawatts that's not being used by the data centers that those power plants could be repatriated onto the grid. And it's because of how a data center is architected and in this utilization. So when I build a power plant to power my data center, I also have to build in some redundancy, right? Because I'm going to be doing some maintenance on that power plant sometimes. So I'm going to have extra capacity right off the bat.
Yeah.
That could be, you know, so I've got a 100 megawatt data center, but I might have 120 megawatts of generating capacity. So right off the bat, I've got extra capacity. I can power both the data center and give back some of that capacity. And then on top of that, these data centers are underutilized by about 2/3. So that 120 megawatt behind the meter power plant might only be drawing 70, 80 megawatts. So I'm actually going to have more capacity, sunk cost. I got to have the power. I got to have all that capacity there just for my data center. But that added margin then is available to go online, to go onto the grid.
It's going to be interesting if they figure that one out. The last one is I have thought about this issue about being open about mistakes that you make in case of liability. But that was before an entire group of predators came along called plaintiff's law.
What is it called?
Plaintiff's lawyers. And as soon as you admit that you made a mistake.
Are there any lawyers in this town?
As soon as you stand up, that's the reason that almost every construction company and everybody, the first thing that's told to them is don't talk to anybody. And the reason is, as soon as you do that, the plaintiff's lawyers come out and say, who do I donate money to for having let you do this?
Yeah,
I mean, they'll slaughter you if you did that.
You're making a good point. In fact, when I first advocated at Microsoft that we should be much more involved with safety, I was brought into a meeting full of lawyers explaining to me what you said, that this is how we do it, Doug. We make it the contractor's problem. We make it the subcontractor's problem, and we're clean. I said, no, you're not clean. You know, was Union Carbide clean when they killed 4,000 people? No, they went out of business. Was BP Horizon clean when they did a joint venture with these third parties? No, they were not clean. So it's a false protection to think that you can transfer these kind of fundamental risk down into the supply chain. But that is a very common trope within the legal system. But, you know, look at the medical practice as an example. What you see is some limits of liability that came in that were legislatively kind of landed on state by state. I don't think we don't do the right thing because we're worried about getting sued. I think that's not the right perspective, in my opinion. I think we need to flag the issue and figure out, okay, how do we solve this? Because we are good at getting insurance for lots of things, and we can certainly insure that. Yeah.
Cool. Thanks everybody for listening to us.
Really good job. Thank you guys. Appreciate you.